Welcome to the DIY Honda Garage channel. The Diagnostic Trouble Code P2101 indicates an Electronic Throttle Control System (ETCS) malfunction in the Honda Pilot models from 2016 to 2022. The ETCS plays a crucial role in managing engine throttle by electronically controlling the opening and closing of the throttle valve, thereby dictating the engine's power output based on driver demand. The throttle body, which houses the throttle valve, is typically mounted on the intake manifold and is connected to various sensors, including the accelerator pedal position (APP) sensor, which informs the powertrain control module (PCM) about how far the pedal is pressed. If this system fails, it can lead to performance issues, including reduced acceleration or even stalling, creating a potentially dangerous situation while driving. Therefore, appropriate troubleshooting must be undertaken to diagnose and remedy this issue before it escalates. The error code P2101 signifies a malfunction within the Electronic Throttle Control System (ETCS). This ETCS is essential for accurately managing the throttle valve, which regulates air intake to the engine. It helps optimize engine performance and fuel efficiency based on real-time driving conditions. The throttle body is positioned on the intake manifold of the Honda Pilot, where it directly aligns with the air intake. Additionally, this component works closely with the accelerator pedal position (APP) sensor, providing feedback to the powertrain control module (PCM). Diagnosing issues with this system is critical because it controls the vehicle's acceleration, which, if malfunctioning, can compromise the vehicle's safe operation. Several potential causes could lead to the P2101 error code, signaling an issue with the ETCS. First, problems may arise from the throttle body itself, including debris buildup, mechanical malfunction, or electronic failures. Second, poor or corroded electrical connections between the throttle body and the PCM can lead to erratic communication, causing the system to register an error. Lastly, a malfunction in the PCM itself could misinterpret signals, thus indicating a faulty ETCS even when it's operational. Understanding these causes is paramount for effective troubleshooting to ensure the appropriate parts are addressed without unnecessary replacements. The symptoms associated with DTC P2101 include a noticeable reduction in engine power, which can lead to frustrating driving experiences and reduced vehicle responsiveness. Drivers may also experience erratic acceleration, where the vehicle may hesitate or surge unexpectedly, compromising safety and control. In many cases, the check engine light will illuminate, alerting the driver to the existence of a malfunction that may require immediate attention. These symptoms highlight the critical role of the ETCS and its direct impact on driving performance and safety, necessitating prompt diagnostic procedures to rectify the issues and ensure optimal vehicle function. In the first troubleshooting step for DTC P2101, the initial action involves turning the vehicle's ignition to the on position without starting the engine. Next, utilize the HDS, or Honda Diagnostic System, to clear any existing DTCs related to the ETCS. This step is crucial for establishing a clean slate for the subsequent diagnostic process. Following this, proceed to select the ETCS test within the HDS inspection menu, allowing for precise monitoring of the throttle control operations. Finally, check for any new confirmed or pending DTCs that may appear, providing immediate insight into the presence of any faults within the system. Each of these actions helps form a foundational understanding of the current state of the ETCS in the vehicle. In the second step, verify the problem by conducting a test drive for several minutes. This driving should be done within the parameters outlined in the recorded freeze data, which includes factors such as engine speed, vehicle speed, and accelerator pedal position (APP) sensor readings. These conditions simulate the environmental factors that led to the DTC being triggered initially. After the test drive, utilize the HDS again to check for any confirmed or pending DTCs. If the P2101 code remains present, it indicates a duplicated failure, necessitating further investigation into the throttle system. If it does not appear, it suggests that the issues may have been intermittent, highlighting the need to inspect for possible poor connections or loose terminals that could affect the throttle body and PCM communication. During the third troubleshooting step, begin by turning the vehicle off and switching to the lock mode for safety. After this precaution, disconnect the intake air duct from the throttle body to prepare for a thorough examination. Next, turn the ignition back to the on position while ensuring connections are intact. Using the HDS, conduct the ETCS test, paying specific attention to the throttle valve's operation. It should operate smoothly without sticking or failing to respond correctly. If the throttle valve operates as expected, proceed with cleaning the throttle body to ensure no residue or debris is inhibiting function. If the P2101 code reappears, the throttle body likely requires replacement. In the fourth step of troubleshooting for DTC P2101, turn the vehicle to the off lock position to ensure safety before proceeding. Now, it's essential to jump the SCS line using the HDS and wait for over a minute to properly reset the system. Subsequently, disconnect the necessary connectors, including those for the PCM and throttle body. At this point, conduct a continuity check between test points specified in the procedure, namely between the throttle body connector and PCM connector. If continuity exists, the SG5 line, which is crucial for throttle body communication, is deemed functional, and you can proceed to the next troubleshooting step. However, if continuity is absent, it indicates an open circuit in the SG5 wire, necessitating repairs to restore the communication link. The fifth troubleshooting step involves the disconnection of the PCM connector C to isolate potential wire issues. Utilizing a jumper wire, connect terminals A and B of the throttle body 6P connector. This allows for a proper test of the MTR1 and MTR2 wires. With the jumper in place, check the continuity between specified points in your PCM connectors. Continuity confirms that the MTR1 and MTR2 lines are still intact and capable of relaying necessary signals to engage the throttle body properly. If continuity is present, the wiring system for these lines is functioning correctly, allowing you to proceed to the next step. Otherwise, you need to repair any open circuits, either in the MTR1 or MTR2 wire, ensuring proper functionality once again. In the final troubleshooting step for DTC P2101, begin by removing the jumper wire from the throttle body 6P connector to finalize your tests. Measure the resistance at the throttle body between two specific test points, ensuring the vehicle remains in the off-lock state during this process. If the resistance measured is around 1.0 kiloohms or more, it suggests the internal circuitry of the throttle body is compromised, likely necessitating replacement of the throttle body. Conversely, if the internal circuit is functioning correctly, further investigation is warranted. This may include checking for any service bulletins or technical information related to DTC P2101 or considering a known good PCM as a substitute to identify possible faults in the system. After completing all troubleshooting for DTC P2101, Ensure to clear all diagnostic trouble codes using the HDS. This action is pivotal as it resets the system, allowing for a fresh diagnostic scan. Following this, take the vehicle for a test drive to observe its operational behavior under various conditions. Pay particular attention to throttle response, acceleration patterns, and any warning lamps on the dashboard. If the vehicle operates smoothly without returning the P2101 code, you can confidently determine that the problem has been resolved. To ensure long-term reliability, it is wise to monitor performance over the coming days to confirm that the issue does not reoccur. To prevent future occurrences of DTC P2101, establishing a routine for preventive maintenance is vital. Begin by regularly cleaning the throttle body to remove carbon deposits and grime that can build up over time and hinder throttle operation. Additionally, inspect electrical connections and wiring to ensure there are no signs of corrosion or wear that could lead to communication failures. Keeping the vehicle's software and firmware updated via the manufacturer can also improve performance and reduce the chances of encountering similar issues in the future. By taking these proactive measures, you contribute to the longevity and reliability of the ETCS and overall vehicle performance. In summary, DTC P2101 signifies a malfunction within the Electronic Throttle Control System, a crucial component for optimal vehicle performance. Thorough troubleshooting, as outlined in this guide, requires methodical inspection of various system components, including the throttle body, wiring, and the PCM. Identifying the root cause is vital to not only address the immediate problem, but also to prevent reoccurrences. Implementing preventive maintenance measures engenders long-term reliability, optimizing the ETCS function and overall driving safety. By being proactive and diligent with troubleshooting, you can ensure your Honda Pilot remains in excellent operating condition. Please like and subscribe to the channel. See you next time.